Hi, my name is Dave Bush and welcome to our race shop. We actively drag race outboards, and I'm here to show you and my buddy Gary Finch what we've been doing on his Johnson Evinrude 3.3. We're attempting to make 400 horsepower on pump gas and roughly 120 pounds of compression. Just a real quick breakdown on what this room's all about is we try to log out in the real world barometric pressure, temperature, and then come back into the dyno room and simulate the real world condition and be able to develop and test and build winning race engines. This project is a Johnson 3.3, and if you look up at the engine, it's got a ton of aftermarket parts, an alternator, 120 pounds of compression, pump gas, and Wayne Taylor's front half. A ton of porting, but we have not cut the back of the engine off like we're known for doing. This is all still stock appearing from the outside. Here we have our main dyno computer, which is a land and sea software system, which is just phenomenal. I can't say enough about that. Could talk for hours about that. Up here we have a lambda meter. We measure the air-fuel ratio constantly. It's a must. Here we have our weather station, which is whether you're racing or dyno testing, this here is a 100% must real-time thing that you need to keep track of to keep your dyno testing in check. Right now the temperature is 74 degrees, 14% humidity, and the barometer is 29.34. We have really good air, 103.7 correction factor, so we should make some killer power today. Over here is a computer that is connected to that actually runs the engine. It's a Vipec V88, new on the market. It works similar to all the other high-end ECUs, but at half the cost. Just a phenomenal piece. Software is just unbelievable. Here we have our fuel table, a correction fuel table based on pyros, our ignition curve. Here we have a flat curve that we can switch real-time on the dash. We can go from a curve to a flat curve. All the various things necessary to run the engine, but most importantly, we have cylinder trims, both ignition and fuel. Here's cylinder 1, 2, cylinder 3, 4, 5, and 6. Here's 5 and 6 to 2 engines that the two cylinders just run hot, really hard to keep alive. But here's our, again, our 5 and 6 map, and those, when you see we'll run the test, they're going to end up being the hottest on the computer. Up here we have our live real-time video, so we know what we're asking the ignition to do. It happens in real time. We use that constantly on the boat, in the dyno room. It's a priceless tool, video, link to all this. Again, we're hoping to make 400 horsepower. We know this one already makes over 400 horsepower, but I'd like to show you guys this, and this should be, hopefully test goes well. Let's go in and check the compression. Okay, we're going to check compression. 120 pounds. Okay, we're back from compression testing. We've got a solid 120 pounds of compression, and we have Chevron 91 octane fuel in this. We've got the engine, or the exhaust fans running, and the exchange fan running that changes air in and out of the room. We're going to have to build a little temperature in the engine. Hopefully this thing will fire right off. It's only 60 something degrees, and it is not starting. So, to get the engine to start, you have to turn the ignition on. So when you turn the ignition on, it helps. We're going to have to build a little bit of temperature in this thing. And what we can do here with this land and sea software is you can click away and just watch the engine. You can ask it to go anywhere. And what we're trying to do is build some water temp before we make an actual pull. We're going to shoot for about 100 degrees before we actually get into it. You can see every cylinder in the collector is really balanced, and the engine's pretty evenly tuned. Everything's on. The water pumps are on. We're approaching 100 degrees. We're going to ask this engine to sweep from 1500 to 8500 and see what it does. Right now it's sitting at around 63 horsepower. But just starting to build temperature, and we will put an auto test and make a pull. There we go. It was a dyno pull, and it was a pretty good one. Turn off all the fans and the engine. I don't know if you can hear it running still, but you have to turn the ignition switch on and off. We just made, this is a record for this engine actually. It just nipped out of 460, actually 477.6, but this is unfiltered data, so it's real-time torque what's happening. And this engine is very, very stable, and it's knocking out a solid 459, 467 horsepower up at peak. At 7,500, it's 468 horsepower. Down towards the bottom, we're in the 360 foot-pounds of torque, which is 355 to 360. This has a really wide torque curve, like you'd expect out of a large cubic inch engine. But the coolest thing that we've been struggling with for years is getting the things to rev to the moon and make horsepower up on the top like a Mercury does. And I let out of the throttle at 80, just over 8,100, and we're still making over 400 horsepower, 418 horsepower at 8,500. So if this should be a really fun ride. This engine is going on my buddy's bass boat, Gary Finch. It's an Allison, and it has just about as much torque as my race boat. Pump gas, doesn't quite have the over rev and peak that we're used to on race engines, but it's over 400 at 8,000, which is just a feat in itself. Very happy. I hope you guys enjoyed this video. We're having a blast doing it. Thanks.